Hi everybody, we're going to talk about one of my least favorite subjects because of the damage they can do to our homes, wood destroying organisms. And this right here is a picture of termites. Termites are visible to the eye. This is obviously blown up quite a bit. They're about the size of like small ants, but they look like white ants essentially. So the first thing I want to point out is that all of these wood-destroying organisms we're going to talk about do serve a purpose. They play an important role in the environment. They clean up wood. If we didn't have termites and powder post beetles and fungus removing all of the cellulose material that piles up, we would be drowning in cellulose material, or there'd be gigantic fires every now and then. And so the way it works, all of these wood-destroying organisms can digest cellulose and or lignin. And without getting too specific into what these are, they're the components that make up the cellular structure of wood material. Okay? So fungus, termites, powder post beetles, that's what we'll be focusing on today. And the important thing to remember is that we need to have one of four things in place in order for these wood-destroying organisms to destroy our wood, decay wood. We need to have moisture of a certain moisture content. We need to have oxygen present. There needs to be a certain temperature range for them to be able to thrive in. And there needs to be a food source. And so if we can take one of these four things is all we need to do. Control one of those four things, we'll be able to stop wood from decaying. Okay, and we'll talk a little bit about that. All right, moisture is maybe the easiest one for us to deal with, and it's always a common source of problems. And we keep coming back to this with like mold and poor indoor air quality, and it's also probably the biggest culprit in inviting wood-destroying organisms into our home. So generally speaking, and this is kind of a general rule of thumb, we want the moisture level to be under 20%. Right here is a moisture meter. It's got these prongs, and you shove those prongs into a piece of wood, and it will give you a moisture reading for that material. What can happen, especially with mold in homes, is we get all of this wet lumber and we put it into our house and we build it so fast, we get it insulated and sheetrocked that we trap all of that moisture in there. Mold can start growing, decay can start to happen. Okay. Under the house is where a lot of decay happens, primarily because we can't see it. We can't see what's going on down there. We don't crawl around under the house very often. Maybe there's inadequate ventilation, but we'll talk about that here pretty soon. Once you get over 28% moisture contact, fungus can start growing on the wood and eating the wood, essentially. Okay. Fungal spores can remain active below 20%. Okay, so the thing to remember is that probably every piece of wood that we have in our house has fungal spores on it that are dormant. And then as soon as the moisture conditions are right, as soon as they get above 28%, they can reactivate and they can start decaying the wood. And then we dry it out and then it slows down again. Okay, so that's kind of something to keep in mind, hopefully. With termites, powder post beetles, there needs to be some sort of moisture present, and we'll get into the details on that a little bit more. Okay, but leaks, whether they're from the roof, whether they're from the plumbing, whether they're a window leak, those are the most common sources of moisture problems in our house, inside and outside the house. And if we can stop those moisture problems, we're going to go a long way in preventing wood decay from happening. So one thing we can do under the house, after we've fixed all the leaks, go into the house and put plastic down, just like we did on the new house that CR built. We're going to roll out 6 or 8 mil polyethylene, I think it is, plastic, and we're going to roll that underneath the house, and we're going to get those big landscaping staples and staple that down so it doesn't just blow away as soon as the wind blows. That's going to prevent a lot of moisture that's creeping up from the ground from getting absorbed by all of the framing materials underneath our house. Providing adequate ventilation is very, very key, okay? Assume that there's going to be moisture accumulating under the house, and then provide a way for air to move around under the house and push that moisture out. All right, here's a picture of a log deck. I always thought that the reason they hosed those log decks down and kept them wet was to prevent them from catching on fire. Maybe that's still part of it, but it turns out the reason is when you totally soak something in water, when it's totally saturated with water, there's no oxygen present. It makes the wood anaerobic, and all of the wood-destroying organisms need oxygen to be able to decay the wood, okay? That one, I mean, other than the log deck example, that one's kind of hard for us to control, okay? We can't really deprive our house of oxygen. Temperature is another one that's kind of difficult for us to control, but it's also the reason why you see petrified wood in the desert, okay? All of these organisms have a hard time functioning above certain temperatures, okay? And I have written down here, fungus aren't active below 50 degrees and above 100 degrees, okay? All of the insects that like to decay wood, generally not active in cold climates or incredibly hot climates. You've probably looked at lumber that we have and it says kiln dried on it. It's got a stamp that says kiln dried. One reason they do that is to dry out a lot of the excess moisture. And then the other thing they do is kill powder post beetles. Okay? The powder post beetles are living in the wood, reproducing in the wood, and then when you run it through the kiln, it can bake them all, essentially, and kill any beetles that might be living in that lumber. But as far as managing our house and managing wood-destroying organisms, that's not necessarily something that we can do. Controlling the food source is something that we can do in the initial stages. So we talked at the very beginning of class about heartwood versus sapwood, and this is a pretty good picture here. This darker part is the heartwood, the lighter part is the sapwood, okay? The sapwood was the living part of the tree when that tree got cut down. That was the part of the tree that was carrying all the sap, all of the sugar-rich stuff that all of these wood-destroying organisms like to eat, okay? So one thing you can do is if you're building a house, if you're putting up trim or something that's going to be exposed to the environment, pick something that doesn't have a whole lot of sapwood in it, okay? And that's one of my big complaints with the second growth redwood, the kind of commercially available redwood that we have right now, is there's so much sapwood in it. And it doesn't matter if it's redwood or cedar, the sapwood is going to get destroyed by termites or powder post beetles or fungus. Picking some sort of decay resistant wood initially, like cedar or redwood, can help control the food source as well, because fungus, termites, powder post beetles generally don't like cedar and redwood. Cedar and redwood are especially full of tannins. That's a chemical that is very unpalatable to all of those things we've talked about. It's like kind of a natural insecticide. Okay. Pressure treated lumber, what we're doing with pressure treated lumber is we're poisoning the food. Okay. We're taking fir or pine or just normal species of wood that in any normal circumstance would just get eaten for breakfast by wood destroying organisms, and we're putting it in this pressurized chamber, punching a bunch of staples in it, a bunch of holes in it, so that the poison can infiltrate the wood. That makes all of the cellulose material in that wood unpalatable to all of these organisms. The thing I've tried to point out in the past is this treatment only goes in a quarter of an inch, an eighth of an inch maybe. As soon as you cut a piece of wood, a piece of pressure treated wood, and look at the end grain, you're going to see a little green ring around the perimeter, and the entire inside of that piece of wood is going to look like a normal piece of fir or a normal piece of pine. Okay? That's kind of the weak point in this stuff. People don't realize that this treatment doesn't go all the way through. Okay, so when you cut pressure treated lumber, make sure you seal up the wood in some way. I used to you can buy the chemical, I don't know what it's called, but they sell it as wood preservative, and it's green, and it smells terrible, and it gets everywhere. You can buy this stuff, and you can apply it to the wood. I've kind of gotten away from that for a couple reasons. One thing is, if you note that they have to punch a bunch of holes in this stuff just to get it to accept the treatment. And that's just the way it is. The lumber we have on the West Coast is resistant to the pressure treating process. I'm not sure what good painting a little bit on the end is going to do when they have to puncture this stuff. Okay, so maybe it's the end grain and it'll help absorb it more readily. But either way, I've gotten to the point where I just paint the end, and I feel like as long as it's sealed up, it's going to help out tremendously. And I've pulled lots of rotten wood out of the ground, and the stuff that's been primed or painted has held up a lot better than something that didn't get any treatment at all. Okay. All right, we're getting into some scary stuff here. Fungal attack. The term is dry rot. We'll talk about why it's called dry rot. But everybody uses dry rot as like a uniform term for any sort of wood decay, but it's very specifically referring to fungal attack. Okay? In order for this to happen, again, we need a moisture content over 28%. Look at this poor wood. It just gets totally destroyed, and it loses all of its structure. So the fungus can digest all of the woody cellular parts that make up the structure. And what can happen is, if this goes unchecked, there can be catastrophic failure in the wood. And same goes for termites and powder post beetles too. They just eat it all apart, and it loses all of its structure. And so one scary thing about the fungus is it doesn't necessarily have to be constantly wet at the site. It's a fungus. It can be underground, it can spread all over the place, and it can draw its moisture from the ground. Okay, so as soon as it gets a foothold, it can go underground and spread roots around and start pulling up moisture because it needs moisture to continue decaying the wood. So it's something to look out for, and kind of the telltale signs are the paint starts to look a little weird. You can look at the side of it, and you'll see that something's happening below the paint surface. It's not flat looking, it looks soft. And as soon as you can start pushing into the wood, you know that you've got a problem, and usually you just kind of need to remove that stuff. I want to talk about why it's called dry rot, because it's kind of interesting. The fungus is present, okay? As soon as moisture conditions get to a certain point, it can start to decay the wood. And so shipbuilders actually noticed this phenomenon where they would be sailing out on the ocean, everything was great, and then as soon as they put the boat into dry dock, all of a sudden it would rot just instantly. Okay, so the fungus was present. When it was out in the water, there was an anaerobic condition occurring because it was totally saturated in water. As soon as they put it in dry dock, there was enough oxygen for the fungus to reactivate, and it could start decaying the wood.